Alright, petrolheads, today we're diving into the world of helicopters. These incredible machines are more than just flying vehicles, they're a testament to human ingenuity and engineering prowess. Forget your Lambos and Ferraris for a moment because these flying machines have a transmission system that'll make your head spin faster than a rotor blade. The complexity and precision involved in a helicopter's transmission are on another level. You see, helicopters need a transmission for one crucial reason: to transfer power from the engine to the rotors. This isn't just a simple task. It requires a highly sophisticated system to ensure everything runs smoothly. Without it, those blades wouldn't budge, and you'd be stuck on the ground wishing you were in a car. The transmission is the unsung hero that makes vertical flight possible. Now, unlike your average car, a helicopter's transmission has a much tougher job. It has to handle the immense power generated by the engine and distribute it efficiently to the rotors. It not only has to change the speed and torque of the engine's output, but it also has to split that power between the main rotor and the tail rotor. This ensures that the helicopter can lift off, hover, and maneuver with precision. And let's not forget, it needs to do all this while dealing with incredible forces and vibrations. The transmission must be robust enough to withstand these stresses without failing. Talk about a demanding job. The transmission is constantly under pressure, ensuring that every component works in harmony. But why is this so important? The transmission's role is critical in maintaining the helicopter's stability and control during flight. Well, the main rotor is what gives the helicopter lift, allowing it to defy gravity and soar through the air. And the tail rotor? It's equally important. It's the unsung hero that keeps the helicopter from spinning out of control like a top. Without the tail rotor, the helicopter would be uncontrollable. Without a properly functioning transmission, you can kiss your dreams of controlled flight goodbye. The transmission ensures that power is delivered where it's needed, when it's needed. So next time you see a helicopter gracefully taking to the skies, remember the unsung hero working tirelessly behind the scenes: the transmission system. It's a marvel of engineering that makes all the difference between a smooth flight and a one-way ticket to disaster. It's not just about getting off the ground. It's about staying in the air safely and efficiently. The transmission is the backbone of helicopter flight, ensuring that every journey is a success. Right, let's get down to the nitty-gritty and talk about what's inside this magical box of gears. The main rotor transmission is a marvel of modern engineering, a complex assembly that plays a crucial role in the helicopter's operation. The main rotor transmission is the heart of the helicopter's powertrain, responsible for taking the power from the engine and sending it to the main rotor. Without it, the helicopter simply wouldn't be able to fly. Think of it like the gearbox in your car, but instead of driving the wheels, it's spinning a massive set of blades. This comparison helps us understand the importance of the transmission in converting engine power into usable force. Now, the inside of a main rotor transmission might look like a jumbled mess of metal, but trust me, it's a symphony of engineering. Each component is meticulously designed and placed to ensure optimal performance. You've got gears of all shapes and sizes meshing together with incredible precision to transfer power efficiently. These gears are crafted from high-strength materials to withstand the immense forces they encounter. These gears aren't just randomly placed either. Each one is part of a carefully calculated system designed to achieve the desired rotor speed and torque. They're carefully selected and arranged to achieve the desired rotor speed and torque. This precise arrangement ensures that the helicopter can perform a variety of maneuvers with ease. And holding all these gears in place are sturdy shafts that can withstand the immense forces generated during flight. These shafts are the backbone of the transmission, providing stability and support. We're talking about forces strong enough to lift a helicopter weighing several tons. The strength and durability of these components are critical to the safety and reliability of the helicopter. To handle all that stress, the shafts are supported by heavy-duty bearings, ensuring everything spins smoothly and without a hitch. These bearings are designed to reduce friction and wear, extending the life of the transmission. But it's not just about brute strength, there's a lot of finesse involved too. The transmission must also manage vibrations and noise, which can affect both the performance and comfort of the helicopter. The main rotor transmission also needs to dampen vibrations and reduce noise, making for a smoother and quieter ride. This is achieved through a combination of precise engineering and advanced materials. After all, we don't want the helicopter shaking itself apart mid-flight, do we? The balance between strength and finesse is what makes the main rotor transmission such a remarkable piece of technology. So there you have it. The main rotor transmission is a masterpiece of engineering, combining brute strength with delicate precision to keep those blades spinning and the helicopter in the air. It's a testament to human ingenuity and the relentless pursuit of perfection in aviation technology. Next time you see a helicopter soaring through the sky, you'll know just how much effort and expertise goes into making that flight possible. Now, we've talked about the main rotor, but what about its little brother, the tail rotor? This often overlooked component is crucial for the helicopter's stability and control. Just because it's smaller doesn't mean it's any less important. In fact, its role is so vital that without it, the helicopter would be almost impossible to control. Remember, this little guy is responsible for counteracting the torque produced by the main rotor and keeping the helicopter pointing in the right direction. The main rotor generates a lot of torque, and without the tail rotor, the helicopter would spin uncontrollably. Without it, you'd be spinning like a top. The tail rotor provides the necessary counterforce to keep the helicopter stable and on course. The tail rotor drive system is responsible for transmitting power from the main rotor transmission all the way to the tail rotor. This system ensures that the tail rotor receives the right amount of power to function effectively, and it's not as simple as just connecting them with a shaft. The drive system is a complex assembly of components designed to work together seamlessly. You see, the tail rotor is located some distance away from the main rotor, often at the end of a long tail boom. This distance requires a sophisticated system to ensure power is transmitted efficiently. To bridge this gap, the tail rotor drive system uses a combination of drive shafts and gearboxes. These components work in unison to deliver power from the main rotor to the tail rotor. Power is transmitted through these shafts, which are supported by bearings along the tail boom. These bearings are crucial as they allow the shafts to spin freely and reduce friction. These bearings allow the shaft to spin freely while minimizing friction and wear. This not only ensures smooth operation but also extends the lifespan of the components. The tail rotor gearbox is another critical component of the system. It plays a pivotal role in ensuring the power is correctly directed and modulated. It's responsible for changing the direction of power flow and adjusting the speed to match the tail rotor's requirements. This adjustment is essential for the tail rotor to function correctly and maintain the helicopter's stability. This ensures that the tail rotor spins at the correct speed to maintain directional control. The precise speed control is what allows the helicopter to make fine adjustments in its heading. So, while it might seem like a relatively simple system, the tail rotor drive system plays a vital role in keeping the helicopter stable and controllable. Without it, the helicopter would lose its ability to maintain a steady course. It's a testament to the ingenuity of helicopter engineers who've managed to transmit power efficiently over a considerable distance. Their expertise ensures that every component works in harmony, providing the necessary stability and control for safe flight. Now imagine this. You're cruising along in your helicopter when suddenly the engine decides to call it a day. Sounds scary, right? Well, this is where clutches and freewheeling units come in, acting like guardian angels of the skies. A clutch in a helicopter transmission is similar to the one in your car. It allows for a smooth engagement and disengagement of the engine from the rest of the transmission system. This is crucial during startup, allowing the engine to reach a certain speed before connecting to the rotors. But where the helicopter clutch really shines is during an emergency. If the engine fails, the clutch automatically disengages, preventing the dead engine from becoming a giant brake on the rotors. This is where the freewheeling unit steps in, allowing the rotors to spin freely and enter auto rotation. The freewheeling unit is a one-way clutch that only allows the rotors to spin faster than the engine. Think of it like a bicycle wheel. You can pedal to go faster, but if you stop pedaling, the wheel can still spin freely. This is critical for auto rotation, allowing the helicopter to glide safely to the ground. So, while we all hope never to experience an engine failure, it's reassuring to know that these clever components are there, ready to step in and save the day. They're a testament to the safety-conscious design of helicopter transmission systems. Let's talk about auto rotation, one of the most incredible feats of aviation engineering and a testament to the brilliance of helicopter transmissions. Remember that engine failure scenario we talked about? This is where auto rotation comes into play. In simple terms, auto rotation allows a helicopter to descend safely to the ground even if the engine packs up. It might sound counterintuitive, but the helicopter actually uses the force of gravity to keep the rotors spinning. Here's how it works. When the engine fails, the clutch disengages, and the freewheeling unit kicks in, allowing the rotors to spin freely. As the helicopter descends, air flows upward through the rotor system, causing it to spin like a windmill. This spinning rotor creates lift, just like in normal flight, allowing the pilot to control the helicopter's descent and execute a safe landing. Of course, this requires skill and practice, but it's a testament to the ingenious design of the transmission system that makes it all possible. The transmission plays a critical role in auto rotation by allowing the rotors to continue spinning freely and independently of the engine. It's a reminder that even in the face of adversity, a well-designed transmission can mean the difference between a safe landing and a potential disaster.